Madam Mercy, can you hear me?
Nakusikia. Ni sawa.
Okay, you can continue.
Okay, asante sana. Hope you are fine and good morning. Today's lesson, we were to look on the exams that you did, the mock exams that you had done. And because I know you have the papers, we shall start with paper 2. We go through the paper 2, all the questions. That is revision of paper 2 exam. And then after we are done, we shall embark on the others. And it is my hope that you are doing fine with yourself, you are reading, you are revising, and you are using your time well. And your morning is a good one, and you are ready to learn. We shall start with the first question, a question that is commonly tested in paper 2. The question on periodicity that we gave you as number 1 question on paper 2 pre-mock exam. It's a very common question. And in most cases now you are given a periodic table like the one that is given there. From that, the question on structure of the atom is tested, ion formation, properties of chemical family members, that is the chemical family, alkaline metal, alkaline earth metal, halogen and noble gases. Then another thing that is tested on the same periodic table is the properties across period 3. That is on their oxides and their chlorides. So those 4 areas are normally tested on a periodic table, and we call, cumulatively, we call that periodicity. And so that was the first question, and it is my hope that you have got the papers. I believe you had been informed that you go through the pre-mock papers. So we shall start with question 1. We shall start with question 1. The question 1 of the periodic table, and the grid is provided. I have put it on the screen so that we can be able to go through it together. The question is, as you can see it, and the grid below is a part of the periodic table. Use it to answer the questions that follows. The letters are not the actual symbols of the elements. And we have the first question there. From the periodic table, identify the strongest reducing agent. A reducing agent is the element that loses electrons. Reducing agent will be the element that loses electrons. And of course, now it will be group 1, group 2, or group 3 of that periodic table, because those are the elements that loses the electrons. And then for the periodic table, the most reactive group is group 1. And then their reactivity increases down the group as the atomic size increases, the ease to lose the electrons increases. For that reason, H is the strongest reducing agent. It is the element of that periodic table that has got the highest tendency to lose electrons. And so H is the answer. We can also maybe frame another question, though not there. If the question was about the strongest oxidizing agent, the oxidizing agent is the element that has got the tendency to gain the electrons. And definitely using the periodic table, it will be a nonmetal. In that periodic table, the nonmetal that has got the highest tendency to gain the electron will be group 7, and in group 7, the smallest. And the smallest there, in group 7, we have Z, V, and G. It is going to be Z. If the question was about the strongest oxidizing agent, then it will be Z. Why? It is the one that has got the highest tendency to gain electron. In a question where then it can be which two elements of that periodic table will be the most reactive, then it shall be that H and Z, because H is the most reactive metal. Then Z will be the most reactive nonmetal. So the combination of the two will give us the reaction that is most reactive using those elements that are given. Now we go to B. In B, we have A. A there is A, and the other one is F. A is in group 4, it is in period 2. So that is 2 is to 4. 2 is to 4 is carbon. Then F is in group 4, and it is in period 3. Therefore, it will be 2 is to 8 is to 4. That is silicon. And the question is about their oxides. For A, it will be A oxide. Definitely that one will be carbon 4 oxide. F oxide will be silicon 4 oxide. Silicon 4 oxide. So in that case, silicon 4 oxide and carbon 4 oxide, they are the ones that now we shall compare. We shall compare their They are oxides. Carbon 4 oxide is a simple molecular structure. Carbon 4 oxide is a simple molecular structure. And so it is bounded by weak van der Waals forces. When there are weak van der Waals forces, I was saying that carbon 4 oxide is a simple molecular structure, and simple molecular structures are bounded by weak van der Waals forces. Weak van der Waals forces structures have got low melting point and low boiling points. Then the silicon 4 oxide is one of the compounds that is giant covalent structure. Giant covalent structure or giant atomic structure. For those structures, they have got strong covalent bonds. And so, right, we are able now to give the difference. We're able to give the difference between the two, the simple molecular structure and the weak, the simple molecular structure, and that is a carbon 4 oxide, which is bounded by weak van der Waals forces, and silicon 4 oxide, which is the F oxide, strong covalent bonded, and it is a giant atomic structure or giant covalent structure. The other question is the chloride of D and F, the chloride of D and F were added in water and stirred separately. When a blue and a red litmus paper were added, different observations were made. State them. D is in group 1 in period 3. Therefore, it is 2:8:1. That is sodium. So D chloride is sodium chloride. When sodium chloride is put in water, when D chloride is put in water, it will dissolve. That one will dissolve to form a solution, a colorless solution, and the pH value of that sodium chloride will be 7. It is a neutral solution. So the observation therefore will be the red litmus paper will remain red and the blue litmus paper will remain blue. Reason? Sodium chloride, dichloride, is a neutral solution. Hope up to that point we are together. On the same note, if it was potassium chloride, it will also behave the same. It will be a neutral solution. Then for the chloride of F, F is in group 3 in period, F is in group 4 in period 3. That is 2 is to 8 is to 4. That is silicon. Silicon chloride is put in water, and when it is put in water, it is hydrolyzed by the water to form silicon 4 oxide and hydrogen chloride gas, meaning it will form a solution that is acidic. And when the red litmus paper is put in that solution of the silicon 4 oxide and hydrogen chloride, it will remain red, and the blue one definitely will change to red. That is for silicon 4 oxide. And the other chlorides that are also hydrolyzed by water are like aluminum chloride, silicon chloride, sulfur chloride, phosphorus chloride. Those ones they are also period 3 nanometal chlorides that when they are put in water, they are hydrolyzed in water and form acidic solutions that changes the blue litmus paper red. So it can also be phosphorus chloride, it can be aluminum chloride, it can be silicon chloride, it can be sulfur chloride. Those nanometal chlorides of period 3. Hiyo swali ingine, that is a D. Using dot and cross diagram, draw the bonding formed when J and Y react. When J and Y react. Before you answer that question, you start by identifying whether the metal is, whether the element is a metal or a non-metal. J is a metal, Y is a non-metal. What type of a bond is formed between a metal that loses electron and a non-metal that gains electron? Definitely that would be ionic bond. And when drawing ionic bond, you simply draw the ion of both. So the ion of J and Y, J will lose 3 electrons. So its valency will be 3. Y is in group 6. So its valency is 2. Therefore, the compound that you are drawing is J2Y3. J2Y3. How do we go about it? Draw J ion. Draw the J ion, which is 2:8. And then it is bracketed and put a charge of 3. And it is J2. Put a 2 in front of the ion. Then the Y is 2:6. It will gain 2 electrons. 2, for it to be an ion, it will be 2:8. Then put a charge of -3. 2. And then the ion are how many? They are 3 because it is Y3. 3 ions. 2:8. And the 2 electrons that are added, they are of a different shading. So if you had used crosses, the 2 added ones are dots. If you had used dots, the 2 added, because they are from a different element, then they will be cross. So that is another area to note when marking, in order for you to earn that mark. The one added, the electrons that are added, the 2 of them, should have a different shading with the ones that were already there. And now the diagrams you have drawn them correctly. I was giving you that 1 minute to draw the diagram, and you have drawn it correctly. And when drawing those diagrams on how to form a board, if it is a metal, non-metal, then the ions of the metal and the non-metal are drawn. And because they have charges, now the force of attraction that we are calling ionic board is the force of attraction of the charged cation and the charged anion. If the question, for example, is now between A and Y, that is a non-metal carbon, and Y is also a non-metal oxygen. So in that case, we are going to draw one for sharing electrons. That is a covalent bond. So I said the first thing is to note, are you joining a metal or a non-metal, and a non-metal or 2 non-metals, like that. State the nature of the compound formed between J and Y. J and Y, then we can be able to name them. J is aluminum, then Y is oxygen. Aluminum oxide is an amphoteric oxide. Other amphoteric oxides are lead oxide and zinc oxide. Their hydroxides are also amphoteric, meaning they are able to react with acid at the same time they react with a base. Compare and explain the atomic radius of D and V. Looking at the periodic table, D is a group 1 element, which is 2:8:3. I mean 2:8:1. Then V is also in the same period, which is 2:8:7. We are comparing elements in the same period. The atomic radius of elements in the same period decreases from left to right. As the number of protons increases, on the same number of energy levels, the pull toward the center increases, thus decreasing the size of the atom. So for that case, D is a larger atom than V. Reason, D has less protons, and so it has got less nuclear force of attraction. You can also answer it like this. V is a smaller atom. Smaller. We are comparing. V is a smaller atom. It has more protons and more nuclear force of attraction. That way. The other one is, what is the name of the group which K belongs? The group is group 8, and group 8, they are given the name noble gases. So those are noble gases. The name the group is given is noble gases. State and explain the difference between the melting point State and explain the difference between the melting point of element V and G. V and G are halogens. Going down the group of a halogen, the melting point and the boiling point increases, because as you go down the group, the number of energy levels are increasing, the size of the molecule is increasing. A larger molecule has got stronger weak van der Waals forces. If the weak van der Waals forces is stronger, then the melting point and the boiling point will be higher. In that case, G, because it is the one that is a larger atom than V, it has a higher melting point. We are comparing, so use the word higher. It has got higher melting point. G has a higher melting point than V, because it is a larger molecule. Then the explanation, a larger molecule has stronger weak van der Waals forces. Higher melting point, larger molecule, stronger weak van der Waals forces. We are continuing with question number 2. I want us to continue with question number 2. And it is my hope that the question that we have done, we are done with it, unless be there is somebody with a question on the topic of periodicity. Because that question has tested on the structure of the atom, the chemical family, and across period 3. It has touched all those questions. If you have got a question on the structure of the atom, chemical families, and periodicity that has not been touched in question 1, if there is a concept that that has not been touched in the question, then you can ask. Extraction of aluminium from the bauxite. Bauxite is the chief ore for aluminium. It takes place in 2 stages. That is the purification to remove the impurities and concentrating the ore to make it purer, and then electrolysis. The diagram, it shows the purification stages. Then we are using the diagram to answer the questions. The starting point there, as you can see, we have the powdered bauxite. Then it is added hot concentrated sodium hydroxide. When hot concentrated sodium hydroxide is added, it dissolves the aluminium oxide, and then we form tetrahydroxo aluminium. Tetrahydroxo aluminium ions. Then we also form the sodium silicate, but now the iron oxide, the iron 3 oxide, does not dissolve in the hot concentrated sodium hydroxide because it doesn't react with it. So it will remain there as a precipitate. Then in the second process, as you can see, now we are separating the residue, that is the iron 3 oxide that did not react with the sodium hydroxide. And now the solution that is containing the tetrahydroxo aluminium ions and the sodium silicate. In that solution, as you can see in the diagram, the aluminium hydroxide is the one that is removed by seeding it out using either aluminium hydroxide crystals, or as in the diagram, by bubbling carbon 4 oxide. In the diagram, the carbon 4 oxide is the one that is bubbled into the solution, and it will help in precipitating the aluminium hydroxide, such that now solution C there will be formed as aluminium hydroxide, as you can see down there, has been precipitated. And then we have got in step 2, where it is heated to form aluminium, excuse me, aluminium oxide. Now we can go straight to the questions. Name the 2 major impurities in bauxite. They are aluminium 3 oxide 1 and 2 silicon 4 oxide. The role of the following in purification process hot concentrated sodium hydroxide. In the purification, it is to dissolve aluminium oxide in the ore, as we have seen. To dissolve the aluminium oxide. Once the aluminium oxide has been dissolved, then what is the role of the carbon 4 oxide? To precipitate. You see, it is when it is dissolved, it is in solution form. And now to separate it from the sodium silicate, then it is removed by precipitating. And so the role of the carbon 4 oxide, why it is bubbled in that solution, it is to precipitate the aluminium ions by forming aluminium hydroxide. And aluminium hydroxide is an insoluble, it is an insoluble substance. So that is how it is precipitated from the solution. And from the diagram, because we have the diagram, there is the other step, that is step of process X. Looking at that process X, definitely that can only be filtration. That one is very simple, as you can see. You have a residue on one side, and then on the other side, there is a solution. How is a solution and a residue separated? By